You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. To answer these questions, I would like you to visit or revisit the videos pertaining the coordinates of pi over 3, because we have to start with pi over 3 here, and the idea of the location of the terminal points of the next few arcs. Because as mentioned, we're only going to use the same figures of the coordinates of pi over 3, but we will be dependent on the location of the terminal points. To do this, let's start with, again, the unit circle here. It's called the unit circle because the distance from any point towards the center is just equal to 1, and all other places as well. But let's proceed to the identity of the coordinates of the following arcs. We are going to start with pi thirds. Okay? Pi thirds is already a specific coordinate, and you can even memorize that if you would like to. And there's also a separate video describing the process of solving such. But if we're going to go back here, pi thirds is again equal to 60 degrees. Okay, in conversion, you might want to review your conversion as well. So it's located somewhere here. Okay, so somewhere here, the point is somewhere here. And it's a combination of x and y. And we're able to show the reason or the process of solving for that. But let us try to move here that the coordinate of pi over 3 is a combination of this x here value. You could see it's almost there. It's just 1/2. And the other partner of that is here, square root of 3 over 2. So again, you can memorize that, or you can always go back to this unit circle and have your analysis for the equivalent degree. So this is the coordinate of pi over 3. These are also the same figures. I'm not saying the exact value, figures 1/2, 3 squared 3 over 2 for the rest of the arcs here. But the point here is, where do we locate the terminal points of each arc? It will depend now, it will greatly affect the sign of this. So for the next item, the coordinate of 2 pi over 3, you don't need to memorize this. Simply, or if you would like to memorize pi over 3 and then understand the location of this. Take note, it's positive 2 pi over 3. So we're going to move counterclockwise, and we know this to be equal to pi. This means our entire pi, the semicircle, will be divided into 3 parts, hence over 3. So we'll have here this division here and that division as earlier for the first answer. So these are the divisions. We have the pi over 3, 2 pi over 3, 3 pi over 3. Of course, we know 3 pi over 3 is just equal to pi. So that's the understanding here. So we divided pi into 3 parts. And since we're moving clockwise, we'll have the first pi over 3 and the second pi over 3 here. Where do we locate 2 pi over 3? It's on quadrant 2. And what does this mean? We are just going to copy the same. They have this. The coordinate of our 2 pi over 3 is on the figures. Okay? This is not the final answer. 1/2 square root of 3 over 2. They're just the same figures. Okay? Even for the next two, we have the same. However, take a look at this. Our terminal point is on quadrant 2. What does this mean? On quadrant 2, x is actually negative. This would mean instead of 1/2 square root of 3 over 2, it would be negative 1/2 because this is our x. Negative 1/2, and our y is still positive, hence square root of 3 over 2. See? We are just copying the figure and we are understanding where is it located. Hence, we can now give its coordinates. That's how you are going to answer this. You don't need to memorize all. Just simply remember the concept of pi over 3 is coordinate, the location of the terminal point, including the movement. Because this is positive, we're moving counterclockwise. Now, how about the coordinate of negative 5 pi over 3? How about this one? The coordinate of that. Okay? Take note it's negative. So we're going to move clockwise. And since it's still pi over 3, so we have our pi here, or negative pi. We will be dividing that into 3 as well. So you will have these regions here. So we have the first negative 5 pi over 3. Negative pi. Second, negative pi over 3. The third, negative pi over 3. And since we are on negative 5, so let's proceed. Negative 4. Take note of that. We're moving clockwise. Negative 1, negative 2, negative 3, negative 4. And surprisingly, this point, which is the terminal point of our pi over 3, is also the terminal point of our negative 5 pi over 3. We're not discussing here this term, but the term for that is coterminal. We will have separate videos for that. This would mean that we have the same point for our pi over 3 and negative 5 pi over 3. Of course, if you don't want the concept of coterminal because it's not yet discussed here, let's just simply look at the location. The location is the first quadrant. And copying this, what happens to the signs of x and y on the first quadrant? Okay, the x is still positive and the y is also positive. Sorry, it's square root of 3 over 2. So it's still positive. Okay, so that is the correct answer for the coordinate. Its location is the same as pi over 3. Also, I did not actually expected this. If you are going to solve for the coterminal, the coordinate rather, I'm just using this notation for coordinate, okay, just for the idea. The coordinate of negative 4 pi over 3 is similar to 4 pi over 3 because negative. So let's move clockwise. 1, 2, 3, 4. We have this point already earlier. That was positive 2 pi over 3. So we'll have the same coordinates as this. They are also considered to be coterminals. So if you don't want the term coterminals, again, it's also on quadrant 2, where the x is negative and the y is positive. Just like that. Okay? So this is our what do you call this one? Determination of the arcs. Now, if you would like to continue and let's say positive, just for the, it's not part of the item, but what if it's positive 4 pi over 3? So we're going to go back to the movement of the counterclockwise. We have 1 here, 2, 3, 4. This is positive 4 pi thirds. The location is quadrant 3. And we know the signs of quadrant 3, right? They are both positive. The x and y are both negative, rather. So we just simply copy the same values. You have 1/2, but x would be negative now. And you have here square root of 3 over 2. Now, also negative. See? We are not changing the placement of one half, the square root of three halves. We are not interchanging them. We're just copying the figure of x and y, but the signs now are very different because the location of the terminal points are now different. So again, you can just memorize or familiarize the coordinates of pi over 3, understand the location of terminal point, including the movement of the arcs is to either positive or negative, and you will simply get the result by taking your time. Thank you for watching.